सभी को नमस्कार। जैसे कि कल मैंने एक वीडियो शेयर किया था यूक्लिड डिवीजन लेमा, उसी का पार्ट 1 शेयर किया था और आज हम इसका यूक्लिड डिवीजन लेमा का पार्ट 2 आप सभी के साथ शेयर कर रहा हूँ, जिसमें हम इसकी एप्लीकेशंस यानी हम क्वेश्चंस फॉर्म कैसे सॉल्व करना है वो सब देखेंगे। फॉर एग्जांपल, प्रूव दैट एनी पॉजिटिव इंटीजर इज ऑफ द फॉर्म 2q और 2q + 1। तो सॉल्यूशन अगर क्वेश्चन नंबर 1 को सॉल्व करना है तो सबसे पहले आपको लिखना होगा यूक्लिड डिवीजन लेमा दैट बाय EDL फॉर एनी टू पॉजिटिव इंटीजर्स a and b there exist unique integers q and r such that a is equal to bq plus r where r is greater than or equal to 0 but less than b। तो EDL को मैं ज़्यादा एक्सप्लेन नहीं करूंगा क्योंकि पार्ट 1 में ऑलरेडी एक्सप्लेन कर चुका हूं। जिन्होंने नहीं देखा वो पार्ट 1 को देख सकते हैं। नाउ व्हाट विल वी डू, नाउ टेकिंग b इक्वल्स टू 2, अगर डिवीजर हमारा 2 हो देन वी नो दैट रिमाइंडर r विल बी ग्रेटर देन और इक्वल टू 0 बट लेस देन द डिवीजर, देन इन दैट केस we have r equal to 0 and 1. So only two possible values, 0 and 1. So case 1, when r equals to 1, we have a is equals to 2q, and when r equals to 0, when r equals to 1, we have a is equals to 2q plus 1. So a was any arbitrary integer, so the first form is 2q or 2q plus 1. So when any positive integer is divided by 2, then all the whole numbers will be divided in these two categories. This is of category number 1 and this is of category number 2. So in first category includes all those numbers which are divisible by 2 or multiples of 2. In second category, all those whole numbers when divided by 2 they leave remainder 1 or 1 more than the multiple of 2. So the first category whole numbers will be the even number as they are the multiple of 2, and the second category will be of odd number. So all whole numbers are divided in these two categories, even number and odd number. Even number will be of the form 2q and odd number will be of the form 2q plus 1. So now next come to question number 2. Prove that any positive odd integer is of the form 4q plus 1 or 4q plus 3. So what we are supposed to do into part A. So again we will write this step again. So we will write this Euclid's division lemma again. And after writing this, then we will proceed taking b equals to 4. Then we know that when the divisor is 4, then remainder will be greater than or equal to 0 but less than 4. That means the remainder will have four possible values, 0, 1, 2 and 3. So case 1, when r equals to 1, r equals to 0, then a is equal to 4q plus 1. Instead of b we will write 4 and instead of r we will write instead of r we will write 0, so it comes out to be 4q. When r equals to 1, a is equal to 4q plus 1. So this is of when remainder will be 2, then a is equals to 4q plus 2. When remainder will be 3, then a is equal to 4q plus 3. So in Euclid's division lemma, in part 1 video, we have already discussed this, that when divisor is 4, then all the whole numbers will be divided in the 4 categories. So this is the category number 1, this is of category number 2, this is category number 3, and this is of category number 4. So 4q, we can also write 4q as twice of 2q, that means 2m, where m belongs to any integer. So this is of the form 2q 2m. So this is an even number as we have discussed in question number 1. Next, 2q plus 1 4q plus 1, here we can write it as twice of 2q plus 1, so that is 2m plus 1. So this is of the form 2q plus 1, so this is an odd number. This we can take from 4q plus 2, we can take 2q plus 1, so that is 2m. So this is of the form of 2q form, so this is an even number where m equals to 2q plus 1. Here we can write it as 4q plus 2 plus 1, and from these we can take 2 as common, that is 2q plus 1 plus 1. So this is equals to 2m plus 1, where m is equal to 2q plus 1. So this is again an odd number. So in question number 1 we have discussed if it is of the form 2m or 2m plus 1. So 2m is the first category number is of form 2m, so that's why this is even. Second category number is of the form 2m plus 1, that's why this is of odd number. Third category number is of the form 2m, so third category number will be even. And fourth category number is of the form 2m plus 1, therefore this is odd number that we have discussed in question number 1. So our question number, so what the question says, prove that any positive odd integer is of the form 4q plus 1 or 4q plus 3. So 4q plus 1 is of the form 2m plus 1, that's why it is odd, and 4q plus 3 is also of the form 4q plus 1 is of the form 2m plus 1, that's why it is odd, and 4q plus 3 is also of the form 2m plus 1, that's why this is odd. The question may also come, prove that any positive even integer is of the form, then in that case the even integer will be of the form 4q or 4q plus 2. So is it clear? So from here we can tell them which category of number will be even and which category of number will be odd. Similarly, prove that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. In that case we will proceed in the similar manner. So in that case, taking b equal to 6, then remainder will be greater than or equal to 0 but less than the divisor 6. So we have the possible values are equal to 0, 1, 2, 3, 4, 5, and when r equals to 1 we have a is equal to, when r equals to 0 we have a is equal to 6q, when r equal to 1 a is equal to 6q plus 1, when r equals to 2 a is equals to 6q plus 2, when r equals to 3 a is equals to 6q plus 3, when r equals to 4 a is equals to 6q plus 4, when r equals to 5 a is equal to 6q plus 5. So when any whole number is divided by 6, then that whole number can be categorized in these 6 forms: multiple of 6, 1 more than multiple of 6, 2 more than multiple of 6, 3 more than multiple of 6, 4 more than multiple of 6, 5 more than multiple of 6, and that can be written as twice of 3q, that is 2m, so that is of the form even. This can also be written as twice of 3q plus 1, so that is 2m plus 1, so this is of the form odd. Here 3q, from here 2 can be taken, from that term also 2 can be taken common, so 3q plus 1, so 2m, so this is of the form even number. Then here you can write it as 6q plus 2 plus 1, so from this 2 we can take 2 common, 3q plus 1 plus 1, so this is of the form 2m plus 1, so this is odd. Next, From here we can take 2 common, 3q plus 2, so that is 2m, so this is even. From here we can write it as 6q plus 4 plus 1, and from here we can take 2 common, 3q plus 2 plus 1, so twice of m plus 1, so this is of the form even. So even form is 6q plus 2, 6q plus 4, and odd form is 6q plus 1, 6q plus 3, and 6q plus 5. So prove that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5. The question may also come, prove that any positive even integer is of the form 6q, 6q plus 2, or 6q plus 4. So question can be molded in any form. अगर आपको समझ आया है और आपको ये वीडियो पसंद आया है तो इसे लाइक कीजिए, सब्सक्राइब कीजिए, शेयर कीजिए. थैंक्स.